Testing your iOS app with XCUI test can be slow, flaky, and quite frustrating. If I run this, for only 2 tests, it's going to use at least 10 seconds. And this is only 2 tests. In most apps, you will have a lot more test cases. The other annoying thing is that these kind of tests are like black boxes. You can't really see what's going on in your apps. So as a whole, they're suboptimal. While I was testing something with SwiftUI, I found a very elegant way of knowing what views are in the view hierarchy in a SwiftUI app. With this insight, I built a testing framework that I'm now going to show you and demo. You can find the whole project and all the files on my GitHub down in the description box. I would also appreciate it if you give me some feedback, some test cases, what you want to see more with this. Now, for this demo, I'm using a project that I already used for previous videos where I talked about XCUI test and also for unit tests. So we have the one-on-one comparison and how this fits in. In order to start testing with my experimental framework, I first need to import the Swift package. So in my project files under package dependencies, I add here a new dependency. This is on my GitHub repo. I will leave the link in the description box. I'm adding this package. Now, in order to see inside the black box of SwiftUI, I have to add some code to the production side, which I don't like very much, but I try to minimize this as much as possible. You will see how much code you will have to add. In the Swift package, I have 2 different libraries, so that I only need to add a little bit code to my production side. So the SwiftLens, this is the name of the package. This is the testing library to my iOS target. And then to the unit testing target, I'm adding the test support. I named this SwiftLens because we all know that the success of a third-party tool goes and falls with the naming, and this is the most Apple-like name I could come up with for something test-related. So I'm adding this now. Sometimes Xcode has a little bit of problem with seeing these. I hope they are improving the package dependencies in the future. Okay, so now that I have this, I want to write unit tests for my app. In my testing target, I create a new file from template. This is a test. You can use both Swift testing and XC test with the SwiftLens package. Just going to use Swift testing. So this is the SwiftLens tests. I need to add here also my testable target. And we can start writing functions. Have a look at the tests I already wrote. So we can just rewrite them with the unit testing style. The first test is I want to test that the items are shown. So these 4 elements are shown in this list. I'm just going to copy the function name. The reason why it's async is because I added some async code so that I can wait for certain UI elements to show up and then do the exertions. This helps with the flakiness of the tests. Now, if you look at the XCUI tests, if you have some UI tests, you know that it works with accessibility identifiers. And in order for XCUI tests to see these identifiers, you need to change something in your UI. If I go to the content view, where I have this list of items, this one accessibility identifier with this helper that gives me the string. This line of code you need to add in order to make your app reliable and testable. Since I didn't want to add too much additional code, I decided to replicate this. First, I need to import my framework, SwiftLens. Then I can add a lens tracking modifier with ID. I'm using the same identifiers here, so I don't need this anymore. Also with this modifier, because I don't want to write too much code, it already includes this accessibility identifiers, so it doesn't do it twice. Now, what does this do? It actually uses a SwiftUI internal, which are preference keys, and maybe I just go back to it. You see here I'm attaching a preference key of a certain value that I defined here myself, and in this I am passing the identifier. Preferences in SwiftUI work the way they pass values up the view hierarchy, and they're attached to the life cycle of these views. So, for example, in order to, which you then, because it's passed up the view hierarchy, on a higher level in your view hierarchy, you can have a look inside. So outside here, I can add a on preference changed modifier with the key. This is the lens capture key, this self type keys. So here I get all the values. So I'm just going to print this. And so you see here, this is one of these arrays. And it tells me it has a list screen of item with this UUID. Then another one with this ID and then this ID. You see there's 4 elements, which are the 4 that are visible on screen. So this UI allows me to remove some. So I can press here, I just remove this. I delete the last. And you see now my array is only 3, 2, 1, and 0. With the help of these preferences, I have a sneak peek inside of the SwiftUI views. I only expose the information, I don't expose internal access. So it's basically, think of it like you have information that from your views bubble up that you can use in the test. Okay, so I'm going to remove this and see how this works from the testing side. So in my SwiftLens test, I need to import on this side also my test support. So this is the SwiftLens test support. Now, in order to catch these preference keys or the information from this UI, I added another convenience. This is a workbench. Here I define my UI that I want to investigate. In this case, we have the content view with this view model that I pass here. And this is the system under test. The function needs to be main actor because I need to render the UI. Maybe just going to go shortly in. So in the initializer, I have here the UI that I want to show. And to this UI, I'm attaching the on-preference change so that I get all the keys constantly updates from what's going on in my view hierarchy. The rest is then rendering with hostings controller and then just that it actually runs. Okay, now that we have this, we can have a look at what this little test environment gives us. And I added 2 different ones, the interactor and the observer. The observer is the one that gives you access to the view hierarchy, like the preferences. I want to check that these views are visible. There's 2 different types because the UI is async, things show and disappear. So we can wait for views to be visible. I actually have these UI elements that start with a certain string and have UUIDs. I don't know the UUIDs. I just want to say, yes, I'm waiting for views that have a certain prefix and I'm expecting a certain count of them. So what was the value that I had? I think I did define this here with this, just the easier way of seeing these. So at the beginning, I have this shortcut that gives me the string values here. So I can call this item function to get these in my test. This is the view ID prefix. This list screen identifies the item, and in this case I just want to have the prefix, so I pass here null. For my setup I should have 4. You can specify a timeout. I put like 1 second. It will fail if the timeout is over because it waits and I want to stop my function. This is throw and async, so it's an await, try, await. So now we are waiting for this. In order to have a proper test, because I'm testing, I use a test show items for initial state. Then I can run these tests. You won't see anything related to the UI. This test passes. How do I know that this is reliable? Let's go back to content view and see how this could be broken. My items come from this view model. So let's say I remove the last one and I rerun my test. This is giving me an error because we expected to have views with this prefix visible 4 times, but it only found 3 here because I only have 3. The whole test now, this one took 1.017 seconds. This is because I have this default wait time of 1 second. If I go back and make the test pass again, it's 0.1 second. So it's unit test speed, which is really nice. And this is also built in a way that you can run tests parallel. Okay, let's now see further how to use this test approach, adding a new item. This is a little more complicated. I need to press this button, go in this field, type here, add this, and then check again. The first thing is I need to change my production code. In content view, to all the places that previously had accessibility identifiers, I now add my custom trackers. For the button, it's not just tracking, it needs to interact with them. I use a lens button identifier modifier, which also includes the accessibility. I need to change the position because I put them as an extension to the buttons, so you need to directly add them. It has to do with the way I hack this, I simulate the button press. Okay, then the next thing is I need to actually see that my view has appeared. This new item view here has a modifier where we attach a accessibility identifier to the whole group. So this I am changing to lens group because I'm bundling some of these modifiers. Then the same is for this button, which needs to go just before the button. And for the text field, I need to do a little bit more extra things. After the text field, I add a text field with the identifier and the binding to the new text item. The reason why I add here this binding is on the one side. For this text field, I'm passing this text in the modifier. For the preference keys that I use to observe this, I am passing the text. You can pass anything that you want to expose, any state, like is this a text field focused, is this enabled? I need this information to expose it to my tests. And on the other side, I'm using it to actually modify it. Now I have these three positions of tracking this text field, this button, and the whole view. We know this view is actually shown when I press on the add item button here. For this add new item function, I again start with my system under test. Then I want to interact and open the sheet. So in this case, I use the interactor and say I tap the button. For this is actually not the right identifier. I want to have the item list screens add button because this one opens the sheet. So in this case, then I want to see that the sheet is actually shown. So in this case, I need to use the observer for waiting for the view visible, which is the other screen. I add here this shortcut to the new item screen, which is in these identifiers, the new item screens, just so I have the strings. So this is the one that I attach to the whole sheet, here to the whole group. So I wait that this view appears, and then I can continue interacting with this. So in this case, I wanted to interact with the text field and set it to a certain value. In the new item screen, the item text field, let's define a new string to new item, new. Next, I need to press on the add button. So this is opening the sheet, writing something in here. What you see is that the button then becomes disabled. So we can write an exception check on this, or wait until it is enabled. This is my new item screen. We can also write the inverse to say when this view appears, then it should be disabled. This is the add button. And then I can interact with this to say tab button. This is the new item screen add button. So when I press this button, this screen should disappear. In this case, I want to wait for it to disappear. So this is the inverse of these. So this is wait for view hidden. And then I want to check how many views are actually visible. So before I knew that I had here 4. This is actually part of the precondition because I need to know that it's now 1 more. Initially, this is also helping if you have some views that are loading later. Always wait a little bit. Then I want to know the initial count. So this is the observer view count with prefix, and this is then the same prefix. This is the raw ID, so I don't need to always rewrite this. So this is the initial count, and then I'm counting again afterwards. I might also want to wait until I have one more, although here I already assumed that it's 4. Since I have access to the view model, I actually know what my expected count is. So I don't need to count this from the UI. The initial count comes from the view model's items count. So we are expecting that we are seeing the initial count. This is the advantage of having access to all my internals. So I can write better assertions that don't fail me in the future. We know that we have these. I can write another weight here to say the initial plus 1. So now I know I have one more. So run this test. I expected a view with this modifier. Where did I look for this? And this is actually here. I did add as a debugger a function to the observer that prints all values. I need to do this before. Okay, so here in this block we see all the views that we're bubbling up. I have 4 times these rows. I see 2 more views on the list screen, which is the button add. I do have all the elements that are on my main screen, but you don't see anything from the sheet. The reason for this is that preference keys don't propagate from these kind of environments. So when I use a normal sheet, it's not going to work. So I have to use a trick and lift the preferences from the sheet one level up. That's why I had to add another modifier for lens sheet that just looks the same. I add another ID. This is an accessibility identifier, so I know that all the elements that are shown are in this sheet. Let's run the test again. That's a little bit of a problem when you're working as an outsider with SwiftUI code. Can't go in and change these. I need to add things. Okay, now we are successful. And you see here, I have this sheet, which actually has 1 children, which has more children. So I'm going to change this. So what I do is I stack them inside one of each other. In the new item view, I had this lens group. Just go in. So preference keys has 1 more modifier. I can inject them and I can catch them at multiple levels, wherever you want to. And I can transform them. So in this case, I get multiple of my sub-children, and then I bundle them and put them, this is a whole list, an array of these views in the hierarchy, that then say, oh yeah, put them all in this one container with this identifier. I did this now kind of double with this sheet, which means here, I'm just going to I'm taking this identifier, and remove it from this block and add it to my sheet here. And this is in my UI identifiers. My add new sheet, just go back and run this again. Okay, so you see, I have here a whole block of these item screens. We can also group them together. I'm not sure if I had one identifier for this. So this is in my main app. After the padding, here I add a lens group with the testing ID's screen identifier. I noticed this might look a little bit strange, but I look at a scope of things. I have UI elements on the main screen together in this screen identifier with children. Or in this screen, I have sub-views with items in this row and buttons. For these buttons, I could add another container, another scope. You can get all these identifiers and fetch their sub-views. You can ask for a preference key, a capture key, for a certain identifier and then check the children to see what views are in there. I did not do that actually here, but we could get the list. This is the SUT observer. The view with ID, this is my item screen, the item list. And this list has then these children. This is this list block that I grouped together. which I actually did not group together with this identifier. Can go back into content view. So here around everything, I just have the accessibility identifier. So now this is the container, representing the container that now has this children inside. So this should now give me this children. So we can print them here. So you see here this array of subchildren. This is similar to searches inside of XCUI test, or if you go for the view hierarchy debugger, only that in this case, I only add these preferences are like little tags that you can choose which views you want to track and how to bundle them. So they make the most sense for you. Instead of having the overwhelm of all the information, you have focused, scoped information that you want to work in your tests with. This is also why you don't have a lot of information. I don't pass crazy amounts, which would influence performance or anything. It's just little information that work next to your app in this different system of preferences. The thing with the scope is a lot of the times you don't want to be super specific about what you want to test. You just want to say that view, that container. And with the help of this scope, you can decide, okay, I want to see here. In this case, I'm waiting for sheet XYZ. You can then add more information to what you're expecting when the sheet is open. That this text field is there, that this button is there, that the text field is empty. We can also check this. So this is expectation to observer, because I observe the text field's text for view ID should be equal to empty. This now should fail because in the beginning it is empty. So it tells me that this is not equal correctly. I need to actually work on the error messages. Sometimes it's a bit tricky. So if I change this to empty, then we are passed. I like to write a lot of assertions in middle steps because they're kind of descriptive. Obviously, if you want to have this more understandable for later maintainability wise, you can write information like text field should be empty when sheet is opened, and so on for the other expectations too. Okay, so this is nice. My test run in 0.06 seconds. So if I run now these two tests, testing the initial state, this is running in 0.068. This is because they run in parallel. Versus these tests, which are like 10-15 seconds. And they have to go one after the other. And they're not so easy because especially here now I have access to all the internals. I can change my testing setup. I can inject properly. So this is rather nice. I will also just add the other two functions so you can have a look at them. So what I also wanted to test is if I press here remove last, then the items updates and there's one less item. So it's pretty much the same code. Only in this case I tap a different button and then I check. I'm waiting here that my view count for this prefix changes to -1, to the initial -1. And then the last one is I tap on remove last until, and then wait here for this remove last button to be disabled. So same initial setup, I count how many elements are there. I wait that they're actually visible. Then I am pressing this button X number of times for each of these rows. And then waiting for my UI to update. This helps with the flakiness, so I don't have timing issues. I'm just here checking that my delete button is actually disabled. If you run this, all 4 tests take 0.085 seconds. If I compare this, maybe I just run all of them. So my unit tests for the view model only, my UI tests with XUI tests. Just need to change my test plan. And then running all of them. Okay, this is not going to take time because of the UI tests. It's a nice before and after effect. It runs them in parallel. It finished all my unit tests, just the UI tests. The UI tests for the view models and the lens tests are already finished. It's just now going through all the UI tests. Okay, everything passed and the whole thing took 28 seconds, mostly because of my UI tests. One of them is like 17 seconds. If you look at the unit tests, so my test for these view models and for the SwiftLens test, where I just have the really fast rendering, no animations, just showing, and also with the advantage of here having these weights. If I only run this, just had to close some of the simulators because I got way out of hand with XCUI tests. Once you run them, they're much faster. If I remove my UI tests, I only have my unit tests. If you look at how long it takes to run both unit tests and UI tests, once I have set up one working simulator, you get an impression of what's the timing. It's more the launching and setup in the background, but the actual tests here, you see the whole 8 tests that I have. So these tests are less than a second. Just need to check how fast they are. If you go to the project tests, you see the slowest add items tests are 0.001 seconds. But down here you see it's 0.09 seconds for the 4 tests. The whole flows with multiple interactions. One of the reasons why it's so fast is because I used preference keys as a trigger, so I don't need to wait to have a manual task which might be flaky. So I really just wait for it to appear and then I continue. I can write these wait calls that hard stop if the condition is not met. That means I don't wait extra. I wait exactly the time for my views to update the UI. Not shorter, not longer. Additionally, I don't do any fancy calculations. I don't need to use introspect like View Inspector to search through all the views inside. I have here this very small array of information, scoped information, that I can inspect and observe. The other thing I didn't talk about here, which I will do in the future, is how I do these interactions. This is basically on the topic of using dependency injection with SwiftUI, how to do this kind of hooks in your UI, and how I actually, the other question is how do I trigger, once I have the information in my UI, like in the SwiftUI button, how do I trigger the actions? Please subscribe to the channel if you don't want to miss this. If you're interested and want to support me, you can have a look at the GitHub repo and report some issues or join the discussion so we can further work on this to make it production ready for your development flows. I think there's already enough usefulness in there that you can start today in using this. Simply because I'm using public APIs from SwiftUI. Preference keys have been there since iOS 13. They never changed. So this is a very stable approach. And you saw it's exactly the information gives me the information that I need, not more, not less. Now this raises the question, because we have these tools, what tests should I actually write that help me in the long run? In the next video, I will do a little bit of a more general discussion of what tests to write, talking about it, unit tests versus, just view model tests, business logic tests versus UI tests with this approach, for example, where all these different things come in play, what's the pros and cons, and what is a practical approach. I like the 20-80 rule. I only want to write 20% of the tests that give me the most benefits of telling me when something goes wrong, but I also don't want to have tests that annoy me in the future. So how do I write tests that are really helping me stabilize and just actually write features, not just redo my testing suite? If you're interested, go ahead and watch that now. Thank you for watching. Happy coding!